Okay, so my name is Simon Lombardo. I'm a tech artist at Epic Game here at the headquarters. Today I'm going to show a bit how to mainly the way we approach FX here at Epic, which is like how to combine material and cascade or Niagara later, and then blueprints to have the effects as flexible as possible and be reusable many, many times. Also, how to make them quite performance by not using crazy heavy thing and 300,000 particles. So you can with GPU particle, but we try to keep everything together. So the idea is to basically recreate this exhaust here from, for example, a spaceship or something like that. That's within a blueprint, and you can easily like change the speed of it, stop it down, change the speed, start emitting smoke, this kind of thing. And I'll go through how to build the material and how to build the cascade for that, as well as how to set it up all together within one blueprint that you can reuse many, many times and change multiple value. Then at the end of that, I'll show you how to access this value outside of Blueprint. For example, if you are interested in cinematic and things like that, many times when we are with client and all of that, there is some trick to access the value much more easily than just add each element inside your sequencer, for example. So that being said, I will do a new level. Can't save that guy. And usually the way we approach is that probably about 30% of the effects is particle, 60% is your mesh with a really good shader that you can easily change and swap and all of that and adapt to what you need. And then all of that is within the blueprint. So the blueprint can drive multiple value within either your material and your effect as well. We use also a lot of, who is familiar with Cascade here? We use Cascade once a week. Okay? We never use Cascade. All right? Who is familiar with the material function and this kind of thing? All right, that's cool. That's going to help me to set up. Blueprint. Who is familiar with Blueprint? Okay, more. That's great. Awesome. All right. So when we do effects, usually the mesh and the UV are extremely important. The way you set up your UV for your mesh is extremely important. In this case, I have an exhaust that will be a cone shape that is empty. And if I look at my UV, I set them up that the bottom of it is the bottom of the cone here, and the top is the top. And I know that when I set up my mesh, and the way I will set up my material, I'll know that throughout the whole process. So for my texture, we use a lot of pack texture, and you're going to get access to that project. But basically, I have a few material here, and if you check, each channel is a little bit different. Those are similar. They're still a little bit different, so I can have variation. That's also saved in draw call because you're doing only one texture, but you're actually using 4. The other one may be a better example here. So I have a ring, and if actually I'll show only the red channel, I know I have the top one that I can use. If I want something more in the middle later on, or mix them together, or the bottom, I have a green one. So packing texture is a way to save a lot on performance. And making your texture seamless, it's also really useful in the way you can reuse them with any mesh, or you can pan them and you can rotate them without having to worry too much. So let's get started, and let's get started with the material from the exhaust. And because the material is a bit complicated, I will start it, and then I will show you the final one, which is basically redoing the same thing over and over to have more variation into it. So I'll right-click, create a material. Open that up. First thing I want to do, a little trick if some of you don't know, select a static mesh and click on the little teapot. And so I have my static mesh inside my material editor, which is really useful, especially when you start playing with UV distortion and this kind of thing. So the next step I will do is that I know that it's going to be a translucent material because I will play with opacity. And I don't want it to be affected by any light. I want it in unlit, so it's cheaper also. And two-sided. So I made it a bit more expensive than a bit cheaper. I try to balance as much as I can. All right, so I'll get my mesh in there, and let's start playing with our texture. So I'll load, for example, this curtain 2. I get my texture, and let's get a color in there. So if you hold 3 on your keyboard and click, you get a constant 3, which is basically a color. And actually, even let's convert that to parameters. Let's call that color. Converting to parameters means that you can access it later on, and you can modify whatever you want, even at runtime. So I'll plug that into my emissive. You can see it here. I don't know if you guys can see. Does that help? Let me get rid of this guy. All right. So now I have my texture in here, and let's say I'll take the right channel and plug it to opacity. So I can see that I start having something in here that's showing a bit what I want. And one of the things you're gonna mainly use when you start doing with texture and material for effects is that you're gonna play with UV distortion, which I will go through after, but also things like paneer. I don't know how to pronounce it, but you basically Alt-P and press, and it's there. So what this thing does is that it's modifying your UV coordinate to push on a vertical or horizontal your texture. So if I plug that inside my UV, and I start to give it a speed, I say 1, then suddenly it starts moving. Is it visible there? Yeah. So that's where your UV are extremely important. I know it's 1 because I know that my UV start here and finish on the other side. If it was inverted, I would have to enter -1. So I'll get my UV coordinate here working. And it's pretty cool, but I have only one here, and I kind of want a second one. So Control W will duplicate your node wherever your mouse cursor is. So if you click Control W, I have a second one. And I will start mixing them together. We do a lot of mixing and blending and all these things. So I'll drag from there, write multiply. You can Alt M on your keyboard, multiply. I'll plug, for example, the green into it. And another thing also really useful, I have a shortcut at the office, but not here. So it's right. You can right-click on any node and say Enable Real-Time Preview, and it's going to just show you that part. It should. It doesn't. There we go. So, so I have it now showing. You can see previewing material here. Also, one of the things is that by default, these guys are all off, which means that you don't see, I have a paneer here, but I don't see them moving. I like to have them all on. So I can see now exactly what's happening without even having to look here. So I see the going up, and now they kind of overlay each other. So we'll want to give a bit of variation. Variation is really important when you do your effects because people are going to see it hundreds of times over and over and over and over again. You want it to don't feel like a loop, right? You want to break that illusion. So the other thing you'll want is to be able to control everything within 1, 2, 3 variables at max within your material. So a way to do that, I know already that I will set up my material to be able to be driven by one float, the speed. So the way to create directly, you can create a constant 1, just holding 1 and clicking, or you can Alt S, which creates a scalar parameter, a float basically, and give it a name. So in this case, I would call it main speed. That will be my main speed. Now, the speed in the paneer comes from a vector 2, which means x and y, or like 2 vectors within 1 input. So if I plug that, that's basically going to be 1. That's not going to work. And the way to set that up, let me set it at 1 first, is that you can append a vector to another. So if you write append vector, now I create a second vector. Now this is different than the multiply. If let's say I multiply 3 and 3, I get 9. If I append 3 and 3, I get 3 and 3. So it's 2 different things. So I'll append this vector, and that will be my main speed. And I know I want it in the white, so it's the second one. Another trick is you can hold Control to any pin, and then you can move them around. It's really useful if you have like 20 inputs into one, and you want to move that, you can just move it with Control. So I'll get my main speed here, and then I'll create just a constant one for the hex. Let's say 0.15. Plug that there, and now I have a new speed, so I'll plug that inside. Now the thing is that I have a second one here. If I plug the same into it, that's kind of gonna be, again, I'm gonna have overlap with my texture. So a small trick that we use often is that, first of all, I'll do this one in reverse, minus 0.015, and instead of plugging the 1 into it, I'll multiply this guy. And I'll multiply by 1.1. So what it does is that no matter if I change these ones, they will still be linked together. But this one will always be a tad faster, so they won't overlap. The last thing you want is 2 textures similar to overlap with each other, because then you break that effects of flow. And I'll plug that into my append and plug that into coordinate. Oh, something is going wrong here. Great to know. Oh, I plugged that into my speed. You see, I made a mistake. I'm so sorry. I plug that in speed. Coordinate will come later with UV distortion. Okay, now it looks more correct. All right, so I'll get this guy a bit further away. Now, the thing is that the thing we play a lot with is what we call UV distortion. Anybody familiar with UV distortion in Unreal here? Okay, one, yes. So basically what UV and texture coordinate are into the editor is that if you hold U and click, you get the texture coordinates. And I'm going to preview that on the plane. And what this is really is just telling where your UV is going. It's two gradient. Let's actually do a mask so it's more visible. Is an horizontal gradient for R or U, and then a vertical one for V. And the thing we're doing with that is that basically you have a value from 0 in the top corner to 1 that way, and then 0 to 1, and then 0 to 1 that way too. So basically you get a coordinate of where the texture is supposed to be happening. Now you can play with that a lot. I'm going to keep it quite simple into this thing, but it's just to show what's possible, and then I'll show also where you can take that too. So the idea is to distort this one, and what it will do is that it will distort your actual texture. And to do that, you will need U and V are basically two, is a vector 2, right? It's two coordinates. So you need something like, for example, a normal map. A normal map, who is not familiar with normal map? Okay, so normal map is basically a way to fake detail inside something by pushing up or down the shadow. But normal map is the only texture that all the texture goes from a value to 0 to 1. A normal map goes from -1 to 1. So it can either push down or push up the file. And we're going to use that to distort our texture. So I'm going to bring that Photoshop file I did into Unreal. I'm going to do the same. I'm going to just duplicate that panel so I have some movement. Plug that into the UV. Change a bit that, maybe 0.05. And do the same trick, multiply. You're going to see that it's always using the same trick. It's just about how you play with your texture and with your UV. Plug that in, say 1.2. Now let's preview that guy. And let me bring back my mesh so we know what's doing. All right. So now basically I have this normal map pushing through the mesh, right? So it's telling, okay, I have a vector in X, Y, and Z. So the only thing I need from that, let me remove my, moving that away. I just need the red and the green channel, the same way I have in my texture coordinate. So I'll do that quickly by just masking. If you grab that and add a mask, sorry, you can choose which channel you want. And right now I just want the red and green. So I'll start previewing this. Now what I get is this. So you can see that basically we're going to try to modify these two with the two same color in here. So let me zoom. Can you guys see? Yeah. All right. So I'll get my red and green, and then I'll add a multiply so I can kind of control the strength of it. Let's put that a bit low at the beginning, 0.5. Now, what I see a lot of time is certain artists also, instead of taking a normal map, which works too, you can take two grayscale and append them together. So you still get a normal map out of it. There's both way it works is the same idea. So now the thing is that if I plug that into my UV coordinates, this thing is going to start to go a bit crazy. Like it doesn't really know what to do because you have black value in there, you have some weird thing. You'll want to add that to an existing texture coordinate. So we'll take the texture coordinate from Unreal. Again, you just hold U, you can get them. And I'll just add that value to my texture coordinate. If I plug that to coordinate into it. Now, if I zoom in, you can start to see that it's taking the texture and start distorting it with the normal map. And I can push that a bit more, but you, of course, don't want to go too crazy. And you can start getting weird distortion. It's almost liquid at this point. Let's put it a bit lower here. All right, so I'll get my distortion happening. on this, and you can start having, you can distort any texture you want. The other thing is that you can also play with your UV when you're mapping your object to get your UV already distorted, so you know that certain flow are going through. We fake that a lot with water, for example. We have one texture passing through, and it looks like it's an infinite loop, but actually, it's just it's the same texture, it's a noise. All right, so I'll get that in now, and I'll plug that, for example, into opacity, and we'll start previewing this thing. All right, so now I get this kind of flow in there going through. The main issue is that, well, I've been blending, adding, multiplying this thing together. My texture is a bit low. Now, I want a bit more contrast into that. Small trick to do that is that you can get something called a power. Be careful with power, it's kind of a bit expensive sometimes, but I'll get a power and plug that in. And what it's gonna do is basically gonna crunch everything. The problem is that my original value is really low. So if I start crunching a lot, I basically start losing it. And one of the tricks we use is that I'll get my original value, I'll multiply it by something crazy, 4. Let me start previewing this thing. The problem is that you don't want a value over 1 in your opacity. You're gonna start to have artifact, noise, and this kind of thing. You don't want a value on top of 1. So you can clamp it. So I'll multiply, I'll push the Y, then I'll clamp it at 1, 0, 1. You can use the clamp. There is a clamp function. The thing is that there is a cheaper way to do that, and you're gonna probably, if like the way we use it usually, is that you can use something called a saturate. And saturate, if you overlay on top of it, saturate is free on most of modern graphic hardware. That's what you want. You want it to run as fast as possible. So using a saturate, what it does is that it automatically clamp it from 0 to 1. If you want to clamp to something other value, let's say 0.5 to 1.5, it doesn't work. But in our case, we just want opacity, so we want to clamp it right away. So I'll use a saturate instead of using a clamp. That saved me, performance on my effects. So that's one of the little trick.
So a saturate is essentially a clamp with a preset value.
Yeah. It's not supposed to make that, it's to saturate also, but in this case, we use it in that way to save performance. Especially that one is, I'm just doing 1 layer right now, but you're gonna see my final material as like 6 layer and things like that. 6-time clamp, yeah, it works. But if you can save a little bit in there, you try to save it.
So why not cheap contrast instead of?
You can use that as well. It's another way.
What's the downside of cheap contrast?
It's not really. Cheap contrast is basically using also the similar power and thing. It's just a material expression that lets you get that faster. It's just each artist work in this different way. In Unreal, we always say there is 100 ways to do something right and one to do it wrong. So every artist has this kind of little trick. I mainly use power, but cheap contrast will work perfectly as well.
Is cheap contrast a newer thing, and people are more used to the legacy?
It might be. I think that's probably come from the way of effects in real time, especially. It's you take it from your teacher. There's not really that many tutorials and that many lessons. So whoever is teaching you, teach you one way. It doesn't mean the other way are wrong.
But you haven't seen anything negative, a downside?
No, not that I know of. That's just the way my master taught me. And I wish he was here in the room today, but he's not, because he could have probably answered more in detail all of that. But there is really different way, but that would totally work. Cheap contrast would totally work. So I get my saturate, I get my power, I start clamping. Okay, so now I start to get this value with some transparency into it, and you can keep adding more and more layer to it. And in this case, just to see it a bit more, we'll want to also get the emissive. You can go over 1. If you go over 1, you start basically glowing, right? So I usually start by a value of 12, but you can do whatever you want in there. So I'll start adding 12. So now I got this kind of glowing thing going on. Where are we at on time, Brian? I would try the material is, I could spend 2 hours talking about material, but unfortunately we don't have the time. I love material. I love them in Unreal. They're super cool, super fun to play with. All right. So I'll show one more trick in this material. So I have my color. Now, one of the other things is that you'll want to save, what you want to save mainly is how many texture I'm gonna load into my material. The less, the better. So one other trick is that, you see in here, it's kind of a bit, excuse my French, a bit crappy, you know, like the side is like, I see the edge, like it's a bit disgusting, right? I want the edge to fade out. Well, I could load the gradient and apply a gradient and start fading it. The thing is that if you remember, the texture coordinate are actually 2 gradients. And they're super cheap because they are, you know, like it's just texture coordinates. So the easy way to mask this guy is that I'll get my texture coordinate, I'll mask my components. So now if I start previewing that guy, I already have a gradient. I don't need to load the texture, right? It's there. So why loading an extra texture? And also, I saw that many times with a client when we review the stuff. A gradient, when you load it as a JPEG or something like that, you're going to start having this noise, this artifact. It doesn't look great. This gradient is perfect. Okay? There is no more perfect than this gradient. I love this gradient.
There's no way to push that, right?
There is.
There is.
That's not part of the lesson, but there is. You can push it, you can distort it, you can mix it. You can get a sphere out of that. Anyway, so I'll get my gradient in here. I'll just do, on top of that node here, I'll just get a multiply. Now if I plug my gradient to my multiply and plug to opacity, hold on, oh yeah, it's previewing here. Start previewing, ta-da! You know, I have a free gradient that I can use and reuse and reuse and reuse as much as I want. So that's another bit of a trick here. So I think now for the material, I'll leave it at that. I'll show you my final one, which is this one. And you guys are going to get all of that. But basically, I'll start getting much more thing, but it's the same, right? I'm just using panner, distorting it, masking it, adding a panner to it. You know, I'll play a bit with add into by pushing that gradient into this kind of thing. I crunch my gradient. I'm using a clamp here. I shouldn't, you know, like. And I add, because I wanted to go crazy, I add tessellation, so it's even distorted, which you don't really want to do. But if you have the performance and the budget for it, go for it. So that's my final material. But that's basically the same thing. It's always the same thing. You append, you distort your texture, you clamp, you multiply, you saturate, you know, and you keep adding. So that's how I will kind of stop it. You guys will have access to all this file, and you can send me a message and stuff like that if you have questions. So you can go, because I could spend, as I say, 2 hours just on that. And that's just one possible material. So there is. So the next step would be to get a cascade going, right? And or particles. So if I get my mesh, now the first step I want to do, I see a lot of people starting to play with cascade, and then they do a really cool effect. And then when they put it in the scene, the effect is either minuscule or is huge, and it doesn't fit with your scene. So I always try to do my effect while having a scale reference for it. So in this case, I know that the scale reference is my mesh. So I'll create just already my blueprint, create a new folder, call it blueprints, and then create a new blueprint actor, and I call it BP exhaust. I'll open that. And so the first thing I'll want to add is my static mesh. So add component on the top of it, you can add the component you want, static mesh. I'll call it am I spelling that right? Anyway, so exhaust static, and then I get my mesh into it. Click my mesh. You can select it in the content browser, then click on the little arrow so it'll send it right away. And I'll get my material that I didn't. I'll get my final material actually, so it looks better. Let me see, that's the way. I get that one, and I'll apply it to it. The same way, you select it in content browser, or you can use the drop-down menu, whatever you want. Okay, so now I have an exhaust here. And you can see there is tessellation going on, so there is distortion as well. All right, so now I can start playing and adding my particles. So add component as well, again, is a particle system. Call it exhaust, actually P exhaust particle. Everybody has their own file name convention. At Epic, usually we start with P for particle system, but click compile, and I'll create my particle system. So new folder, particles. And if you right-click, it's there on the list right away, particle system. and I'll set up that in the template. Now, what I want for this exhaust is I want some sparks from time to time, just a bit of sparks going on. And then I want to add some smoke, but also be able to control when that smoking is going and how much smoke is going. So I want to be able to control all of that in real time at runtime. I want also my spark to be adjusted based on my exhaust color. So if you remember, in the material, I have a color parameters here, so I can change the color of my exhaust and it will change. So I want that to drive my particle color as well. I don't want to have to go to my particle system, change the color, go to my material, change my... I want everything to be linked together. One value drive them all. So it's a good slogan. So now I have my blueprint here and I have my particle. So the first thing is I want to create the gradient, the sparks, the material for my sparks. So I'll go back into my material. Oops, here, create a new material. Okay, sparks. And one thing you would want to do if you're not familiar with Cascade is that Cascade can override color in your material. It can override a lot of value in your material. And the way to do that is two ways. One is a particle color, which basically will let Cascade output a specific value for a color. And so you can link that to opacity for the alpha or to a color for the color of the particle. The second one that I will not have the time to show here is called particle dynamic parameters, which basically give Cascade 4 parameters that can drive anything from time to blend to the power to animate that gradient. All of these things can be driven directly into Cascade, and that drives your material as well. Erosion, this kind of thing. Unfortunately, explaining that will take me already 1 hour, so I'll have to skip. But OK, we get a particle color. We want our particle to be translucent again and unlit. We don't need two-sided. For the color, I'll just plug directly the particle color into emissive. I don't want to deal with that in my material. I'll deal with that within Cascade. For the opacity, I would like to have something, right now is a square, right? I would like to have something like a gradient. And there is something called sphere mask. But if you have a recent version of Unreal, and you go to engine content, and then you have like a new folder here, and you write radial gradients, you have a secret material function. Actually, you have a bunch of them in there that are not meant to be used right away, but there is a lot of cool stuff that tech artists have been doing and put in the engine, and they're not yet exposed, but you can access them. So you drag that guy in, and that basically will create a radial gradient for you. Very simple. You can use a sphere mask. That's the same thing. It's just like one of the way of doing it is that I like to. There is so many like cool material function in there.
What's that function?
Very simple. Is a sphere mask already done? You can redo it by hand, or you can just load that one that's already been done. It's kind of a way to save time. So stop reviewing. But there is a lot of, one of my favorite is like a chaos 4-way that basically blends a texture based on 4 corners, so it makes a texture seamless. You know, there is a lot of. You could spend a day looking through all of those, and it's pretty fun. I would really suggest to do it. So they are in engine content, and to see that, you have to click on the view option. So I'll get my my spherical mask here, and I want to multiply with my cascade value coming in. I plug to opacity, and then I basically get a simple thing, and it's pretty cheap. No texture loaded, it's gonna look great. So apply that, save that, and go back to my particle system. I'll go back to content. Like that. All right, so now in Cascade. Cascade can load a bunch of emitter. As I say again, sorry if some people arrive late, no Niagara. So, but maybe there will be one of this lesson done with Niagara, but that's not the case today. So I'll explain just within Cascade, which the theory is kind of the same. Well, kind of. But we want to create a particle. So when you create a Cascade emitter, a particle emitter, Cascade will already set up your first one as a simple spawn with the crosshair texture. So if I go back to my blueprint, I can see that it's there. So let me do something like, maybe if I do that, and which one it is? That works. Yes, that works. All right, so I can see here I have my blueprint with my particle system, and here I have my particle system. So whatever I change, I can see it right away within the other side. So the first thing we'll want to change, obviously, is get our spark material. If you're in the material editor, you can click the magnifier glass here, then go back, and in require where you want to put your material, just click on the little arrow. So it's going to compile, and really it's going to do its thing. So you can see scale is important. Right now, my particles are way too big, at least for the effect I want. So the first thing I would do is probably rotate my particle here. All right, deselect it so I can start seeing it. And let's maybe change its initial size. So cascade, you can have multiple emitters on top of each other. And the cascade is basically one unified system, right? Let me remove this guy. Then you have something, I'll go quickly over a bit. The require is basically where you put your main setting for your emitter. The material, how long your emitter is staying, what kind of depth sorting is doing, this kind of thing. Spawn is basically how many particles you want to spawn, right? I want to spawn much more, or I want to spawn 0, 1, you know, because it's, yeah. That's basically that. Lifetime is, of course, the lifetime of the particle, not the particle system. The particle system lifetime is in require, emitter duration. So that's the lifetime of a particle. Then you have initial size. Everything that's called initial means it's set up at the beginning of the particle. When the particle is born, she gets that value, and that's all. Every node that I call overlife will use the life of the particle to apply a different value depending on their life, right? But I'll go more into that now. Let's first change the size because, you know, like that's a bit big. So initial size. And because in require that's a square, texture is a sprite. Texture sprite is just a square. Changing the size in one value will basically change in all of them. So I'll do that maybe 1 and minimum 0.5. So what this does, a vector uniform will basically when the particle is born, she will get a value, it will get a value between 0.5 and 1, and it's a random value. So now the thing is that I would like them to be more like sparks and maybe a bit long and all of that. So the way to do that is Unreal give you the opportunity to, instead of having screen alignment, you can choose velocity. And that will stretch the particle based on the velocity. So now this scale is decided in the, I think is the while. Yes, you can change the while, and then basically it's gonna scale. I obviously put a crazy value here, 250. But you can then scale your particle much bigger that way. So I'll put this one a bit smaller, and maybe this 1 to 3, 10, 15. So now I get this, maybe a bit too big. It's 6. Okay. So now I get this kind of, you know, they stretch based on the direction and the velocity. All right, so that works. Color over life. That's where we start to think about how we're going to approach that. I want the color to be able to change based on the material of my exhaust. I don't want to, you could come here and I can say the particle, okay. Let me explain first this for the people who are not familiar with Cascade. What this does, you can see that you have a constant curve, what's called a constant curve. You have an in value and then an out value, which is in this case, depending on the module, is a color or scale or this kind of thing. The in value is what we call the normalized age of the particle, is the age of the particle from 0 to 1. Even if the particle is 10 seconds, can stay alive 10 seconds, it's still 0 to 1. So at 0, when the particle is born, get this color. At 1, when the particle dies, get the other color. Right now it's only white. So I could come here and say, okay, I want the same color as this. I kind of get it. Okay, that's kind of working. But then if I change my exhaust, especially at runtime, I'm kind of a bit stuck in there. So usually, that's again, as I said, there is 100 ways to do things. That's the way I'll do it, is that I'll put my emissive value here. So I know that usually I play with 12, and I'll leave it white. I want 12 emissive white. That's all. I'm not touching anything else in there. But I'll add another one. So if you right-click, you can add module. I'll add a color called scale color over life. Again, it's an overlife. So it's a, you know, from 0 to 1 of the particle. What the scale color over life does is that it will multiply whatever value you feed them in to your original color. But in that case, I don't even want to start doing thing overlay. I just right-click on it, and you see there is this little thing called Setup Particle Parameters. If you click that, it will ask you a name. And then it will ask you a bunch of value, which I usually don't change in here, but we'll give it a name color. And that will be that we will be able to access that value from outside Cascade at runtime. We basically create an anchor for us to comment the particle system while we are outside the particle system. And a lot of nodes, not all, but a lot of them have this function as well. So now I have my color set up, I have my spark set up. I'm pretty good. I'm going to go on with the smoke. So I'll right-click on my emitter just to give it a name. You can right-click emitter, rename name. Call it P sparks. And I'll create another emitter in there, so a new particle system. And it's automatically taking the texture that was selected in my content folder. So in this case, this thing. But we want smoke texture now. So I'll go there, and I'll do my smoke material. I'll go back here, and let me save just in case. And I create a new material, empty smoke. Now for the smoke, we'll use what we call a sub-UV texture. Who is not familiar with a sub-UV texture? You don't? Okay, so I will explain quickly what it is. So a sub-UV texture is basically kind of a flip book. Let me see if I can make that bigger. So it's basically a series of images from an animation. And what the engine can do is that it can read one, and then another, and then another, and another, and basically on a sprite with one texture play an animation. We use that a lot for smoke or certain time fire and this kind of thing.
How do you produce that?
You have multiple ways to do that. Each has its own little secret recipe. I use Houdini, but you can simulate that. And After Effects, I think somebody put a template online where you can load like as many pictures as you want, and After Effects will output that for you. You basically render them and then just set them up. They need to be always centered correctly. Houdini has a script to output directly like that. There is a bunch of, especially with Unreal, it's really compatible. You can export a lot of things from Houdini. But I use FumeFX. I just render my picture, load them into Houdini. I'll simulate in Houdini and render it directly in there. There's multiple ways. We can maybe talk more about it later if you want.
Does it matter? I guess it does. Does Unreal look for the same pixel size?
Yes.
Every time?
Every time, same center, same pixel size. You cannot have, it's not a texture, it's kind of a texture atlas, but you cannot have as much flexibility. So here I have, for example, this smoke animation going on, right? The smoke is puffing and stuff. And I have an alpha, which is great. So let's do our material for the smoke. I'll open my smoke material. I'll get my texture. And then as before, I want Cascade to control thing about it. Now, I don't want to control the color. The color is already baked in. I like it. I want to stay that way, so I'm not going to do the same. But I want to control the opacity. I want to be able to blend my particle over life. So it spawn and then suddenly fade away, right? You don't want them to pop away. So the way to do that is that, first of all, I'm going to plug my base color. I want also the smoke to be affected by the light of the exhaust, so I will not do an unlit. But I will do translucent because I want the opacity. So I'll get my opacity from my particle and multiply it with my alpha from my map. Now, I could plug that in, and it will work. I have my alpha, and I will be able to fade it. But there is another problem. It's usually when you spawn particle, especially with particle sprite and things like smoke, when they got close to another object, you have this kind of odd edge, like you see your sprite and it looks really video gamey and all this kind of thing. Well, Unreal gives you the opportunity to get rid of that thing, and it's called a depth fade. So what this does is that it has a unit, the fade in distance, and based on that unit, when the particle, that material will come close to another object within that unit, it will start fading out. It will start to disappear. So if the smoke is going against the floor, then the smoke contact with the floor will not be an odd edge. It will be like blended together really beautifully. So I'll use that for my smoke. Especially with the exhaust here, you don't want the smoke to look hard edge against the cone of the exhaust. You want them to blend together like they are not really there. All right, so I get my particle here. I'll save. And I go back to Cascade. Now in Cascade, I'll load my material by selecting it inside here, smoke. And I'll plug it in require. You can also, in Cascade, you can use the little S here that will basically solo out your emitter. So you can see one emitter at a time. It's really useful to be able to work on. Now, if I see this one, you can see it here. Another trick also in Cascade, the same as the editor, you can do Alt2 for wireframe, Alt3 for unlit, Alt4 for lit, etc. So I will work a bit in unlit. So you can see that now what is spawning this. We don't want him to spawn that. We want him to spawn and then blend from one picture to another. So the way to do that is that you just need to tell Cascade, well, hold on a second. This is not a normal texture. This is a sub-UV. So if you go to your require and you go down, you will see something called sub-UV. And then you have different modes, linear blend. I advise you to experiment with it, but it's pretty straightforward. What interests us is a linear blend, which means it will go in order from one to another and blend in between them. And then he asks you, okay, how many image on horizontal and how many on vertical? So if I remember well, that was 8 and 8. So I just write, 8 here, 8 here. Now you can suddenly see, okay, he's spawning only one of them. He's not spawning the whole thing, he's spawning one. The problem is that he's still not playing through them. Well, you need to tell a Cascade to play through them. So the way to do that, there is two methods. There is the sub-UV. If you right-click into the gray area, there is sub-UV image index and sub-UV movie. I'm not quite sure the difference between both of them, but they kind of do the same thing. It lets you play through the particle, the flipbook. I'm used to sub-image index. I think sub-UV movie lets you change the frame rate at which it plays. So it's newer. So I click sub-image index, and again, we have this curve with the in value and out value. And that's the normalized age. Everything in Cascade works that way. You have a normalized age when the particle is born, when it dies. There is a way to go into detail here by having a better blend, by dividing the number of pictures by the percentage, so you get a not full number, and then depending on the frame rate. I will not go into that here. I will keep it simple. I want my in value to be my first frame, frame 0, my last to be the last frame. And because we start at 0, 8 by 8, 64, right? Yeah, I think so. So I'll add 63 because we start at 0. So now what's happening, let me spawn only one particle, is that it's spawning and playing my flipbook. I don't know if it's visible there, but the particle is basically blending between all of the image from the flipbook and animating that smoke. But it's still only one particle. Nothing is really animated, actually. The only thing we really animate here is the UV. And it looks like it's playing. So now I got my smoke here. Let me rename that emitter. Smoke. And let's start spawning a bit more of them, 25, maybe 20. All right. Now I want to control how much I'm spawning of those. And if you see on the rate, there is the constant, which is how much per second you're going to output. And then there is something called rate scale. And rate scale is just a multiplier. That means that if I multiply, it will multiply that number by this one. It's kind of a override control over everything. So if I write 0, you emit nothing. If I write 10, it's 10 times 20. So you can easily control that. So I'll put it to 1, but I want to control that thing. And you remember before we basically right-click on one to create the parameters. You can also click on this one and create the parameters from it. So if you click on any of those, you can access them from outside Cascade at runtime. So in this case, I want to control the rate scale. I want to be able to say, I want no smoke. I want a little bit of smoke path. I want a lot of smoke. Maybe not that much. But so I'll do that by creating a particle parameter. So I'll click that, same as before. Ask me a name. I will call that smoke emit. And then some minimum output value in case you want to stop to go too far. And a constant, which is the default one. In this case, I'll put 1 so I see what's going on. Maybe this is a bit too much. The last thing I want to do is that, well, this guy are kind of spawning and playing and all of that. I want to start to play with, maybe have them scale over life and become bigger and fade more easily together. So if you right click, if you go to size, there is size by life. And basically this will also multiply your thing, normalized value the same way as we did before. There's a square particle. So you see, if I put 20, then it starts multiplying like crazy. I want a bit, and then they start growing up a bit. The other thing I don't like is that if I want to use that for a smoke trail, they're gonna basically spawn and then be pushed. I want them to be pushed and then slow down really quickly. So a way to do that, there is multiple ways. You can also change, you can change either the velocity of a life. Say, okay, you get a velocity when you're born, and when you die, I want you to have 0 velocity. But there is another way that's, for me, easier, is to use a drag. Drag basically add friction to your particles. They will slow down over the lifetime. So if I put that, then they go out really quickly, then they stop stopping. And you can, if you go really crazy, you can see the thing becoming smaller. You don't want to do that too much, but a little bit, especially if you want to have your exhaust and have a trail over them. So they will be pushed when they are born, and then suddenly slow down, grow, and then disappear. How are we in time, Brian? Okay. All right. So we're happy with our smoke. We'll go to the next step from there. But there is a way to push that even more, of course. And the project I will give you is much more advanced than that. It's just I don't have the time to go through everything. So I close already that. Yes, I'll save all of that. Perfect. Now I reopen my blueprint. And I have my exhaust here. The last thing I want to do is add a point light in my blueprint. I got a point light. And the reason is that I want also the exhaust to be able to control lights around it. So if I put a plane here, right now there is no light. And if I take my exhaust and put it there, I can see I have a light based on that. But I want also this light to be controlled with one value. So my point light, I'll put it, the attenuation a bit smaller, the strength, a bit smaller as well. I'll leave it white for now, because the same way we did the spark, we're gonna control everything within Blueprint. So if I go into my construction script is a way to create and modify Blueprint while being in the editor. But you can also apply whatever I'm gonna show you here at runtime, calling it from a timeline, calling it from custom event. I'll try to go through that also. But I got my construction script. So the first thing I'll want is my exhaust, the mesh. So you can drag it from the view here, from the component to that. And I want to create a dynamic material instance, which basically means an instance of my material so I can change value. Click that in there. I'll know which material it is. It's that guy. Click there. And I'll promote that to a variable. So that would be my exhaust mat. All right, so I have my material here. Now I can start playing with that material. So I'll get my exhaust mat, and I'll want to change the color. So if you just write color, Unreal knows what you're talking about, but the correct name of the node is called set vector value, with a vector as a color. And he's asking you a name and a value for it. And I'll plug that in. And if I go into my material, we remember that, again, names are really important. If you write it wrong, then it's not going to work. My material here is called color. That's the one I want to access to. So I'll just write color here. And I'll promote this to a new value. So I'll promote it and call it main color. Compile that. Now the main color by default is black. So I'll come here just because it's easier. I'll right-click in the color, copy, and paste it in this one. If I compile, okay, no change, everything seems to be okay. But now if you click on the little eye here, you see there's an eye closed, and if you click on it, it opens. That means that I can access that from the editor. So if I minimize this, and I'll go to my exhaust here, and then I'll start playing with that color, then my material is changing. And that's in editor and at runtime. So you could have like multiple, you build one exhaust and then you can reuse it as many times as you want. Now, the second value I wanted to change is to have this color changing the sparks and changing the point light. So I'll take my particle, drag it in, and then if you write color, there is set color parameters, and we remember the name, if I'm right, was called color. Plug them in exactly the same way. I'll plug the same color to it. If I click compile and I didn't do anything wrong, you can see that my sparks are now blue. And if I go in my editor and I look at my sparks, if I change the color of my spark will change. And they will be always the same as the exhaust. So I don't have to go back into Cascade to change that. Now, let's go back to our blueprint construction script. Now, the point light the same. I just drag the point light and set color and plug the same one. Now, if I compile, now my color is from the light is also the same. So the three of them are changing at the same time, and you can add whatever you want into here. Now we want to change the speed of it too, or more stuff like that. So you can do the same. So we have the exhaust maths. I can say I want to change a float parameter, set scalar parameter value. And this one was called main speed, I believe. And I'll right-click on this guy, promote to variable, main speed. Click the little I, and make sure to connect them. Now let me reorganize this a little bit. I'm a bit OCD with my blueprint, but you can double-click on any line to create a reroute node. All right. Main speed. So now this main speed by default is 0. So if I go inside the editor, I can see nothing is moving. So I will have to change it here. So I can add 1, 2, and you can start having crazy speed out of it. And this can be driven through blueprint, through sequencer, through timeline, whatever you want, through even other blueprints. So you can have your ship that when it's getting a certain velocity is driving that speed for the exhaust. And for example, if the exhaust goes over a speed of 1, it starts triggering the smoke and this kind of thing. You know, so you can start having, the smoke, yeah. The same way, we'll get the particle exhaust, scalar, floats. Set float parameters. That one was called a smoke emit. Smoke emit, compile. Connect that through it. All right, and now I click the little I, and I have a smoke emit that's default by 1. If I press 0, if I press 1, it starts emitting smoke. If I press 3, it starts emitting more smoke, etc., etc., etc. So you can drive all of that through logic via blueprint. So you can create an FX, but then you can marry it with a material and marry it with a blueprint, and basically have this thing works in harmony together to create an FX that can be easily changed, can be interact with, and can be reused many, many times. So the last thing I wanted to show before to do a quick Q&A is that if you create a sequencer, so I create add level sequencer, for people who are doing cinematics mainly, is that if you add that blueprint through the sequencer, you have the track. And you can, of course, start selecting, OK, I want to change my particle color. I want to change my point light color. But you set them up here already. So a little trick is that you actually click on the variable, and there is something called expose to cinematic. If you click on that and compile, let me do that for all of them. Now, if you click back on your sequencer, the property are directly available right there. So you can create one main speed and start keying that one right away. So it's easier than start getting into the FX itself. Now, if you have also custom events where you have something, OK, if the ship goes as fast as that trigger, then you can also do that. There is one thing I need to mention is that if you do get the variable as cinematic, you will want to be able to run it at runtime. So it needs to be plugged inside the event graph, not the construction script. But yeah, I hope you guys learned some stuff. And I'm sorry I went really quickly through a lot of things. And again, sorry, it's not Niagara. But if you have any question, you'll get the file also. There is a PowerPoint. And I can be reached anytime if you have more questions.